The project that you are being presented with today is entitled Native Assemblies, Geo-Digital Hybrids. Through the use of today's digital tools and computational applications, this overall body of work aims to provide designers with a reconditioned approach as to how we can start to both formally and aesthetically address architecture that instances itself within the natural environment. In reference to past historically distinct relationships between architecture and its natural surroundings, opportunities arise in today's discourse to reconsider how artifacts with similar settings, but departing intentions, can be made through a new set of contemporary logics. To consider these artifacts as a physical enmeshment of their environment, rather than a separate structure of its own agenda, this project suggests that not only can the materiality of our designs be derived from their natural context, but also, so can the formal and spatial qualities of the architecture itself. As a way to employ specific scenarios within today's context, the project distributes to the areas of Sulam, Hong Kong, North Rim, Arizona, and Denali, Alaska, where there is an increase in demand for residential housing, and a future outlook of degradation in their environmental character. As to how these residential units could be designed, the project explores conceptual approaches derived from Stephen Kellett's writings on biophilic design by reconfiguring primitive geometries as decontextualized objects with inherent biomorphic qualities. In contrast to this previous use of solely visual referentiality, the project turns to the use of contemporary surveying techniques, such as photogrammetry and LiDAR scanning, to digitally reconstruct the native geological features and repurpose them as a newly found design medium. Following this, the project utilizes different computer vision processes and environmental simulations to extract what would serve as the residential footprint and its overall bounding volume. As a way to hybridize these artifacts with naturally found geographic features and programmatically man-made structures. The environmental features scanned were then split and processed through a particle simulation that is constrained by the previously generated volume. To further develop native material information, the project introduces what are called diffusion models as a way to collect referential data that was unable to be surveyed and applied in the previous processes. In terms of fabrication, the project utilizes the stereotomic methodology of slicing and carving from naturally found stone via CNC machining processes. The carved units are then systematically stacked as interlocking lithic components joined by simple mortise and tenon joints. And finally, to demonstrate how native assemblies could be implemented, the following visuals portray each instantiation of the developed artifacts within each of their own contextual environments.